Okay, thank you very much for this session. Today we are going to start this chapter 3. My name is Ntayo Asafa. Today the chapter 3, transportation and assignment problem. Therefore, after completing this transportation and assignment problem, you are going to understand these are the 3 basic learning objectives that you should bear in your mind. And the transportation and assignment problem, normally it is a continuation of the linear programming model, which is with the objective of minimizing the total transportation costs, taking into account the origin of supplies and the destination of demands. Therefore, so as to provide a solution set for the transportation model, first we are going to see how this transportation model will be formulated. Therefore, in order to formulate this transportation model, typically this problem works for the transportation assignments which with the display of origin and their destination. Therefore, in order to formulate a transportation model, these are 3 issues that you should bear in mind. The first one is supply quantity of each origin is displayed, and the demand quantity of each destination with unit transportation costs. Therefore, these are the 3 basic issues for formulating a transportation model. Then there are also the basic 3 assumptions for this transportation algorithms to be true. The first one is all goods be homogeneous, so that any origin is capable of supplying any destinations. And also the other one is transportation costs are a direct linear function of the quantity shipped over any route. And the third assumption is the total quantity available is equal to the total demand. Therefore, for example, take an example. This Harley Sand and Gravel Pit has contracted to provide topsoils for 3 residentials, so farm A, B, and C, with their weekly capacity of with cubic tons of 100 A. Farm B is capable of with weekly capacity of 200 tons, whereas farm C with 200 cubic tons. And with the demand, these 3 projects are requiring this much tons of sand and gravel from the previously stated farmers. Therefore, project 1 with 500 weekly demand, 50 tons, whereas project 2 with 150 and project 3 with 300. Therefore, based on this, and also these are the 3 farmers with these 3 projects with unit cost available. Therefore, all the 3 conditions are now satisfied, and also we can formulate directly the transportation model. Therefore, here you can put in the left hand side of your Coleman value these 3 farmers, farm A, B, and C, with their total demand. And also in the right hand side of top margin, you can state also the 3 projects 1, 2, 3, and the supply here. Therefore, farm A is capable of supplying 100 cubic tons, whereas farm B is capable of supplying 200 tons, whereas farm C is capable of 200 tons with these projects. Therefore, in order this to be considered as a transportation model, the demand and the supply should equal. When you sum these values, and summing these values will equal this 500. Therefore, now this is a transportation model with this given issues. Therefore, the next one is finding an initial feasible solution. Therefore, to find an initial feasible solution, that is to find the total cost which is incurred by this model, the first condition, there are 2 conditions should be fulfilled. The first one is a feasible solution is one in which assignments are made in such a way that all supply and demand requirements are satisfied. Here you can see also these are 500. When we sum the demand also 500. Therefore, all supply and demand requirements are satisfied. And the second assumption here in finding an initial feasible solution in this transportation model is the number of occupied cells should equal 1 less than the sum of the rows and the number of columns. Therefore, here in this case, there are 3 rows and 3 columns. Therefore, the feasible solution is 3 plus 3 minus 1, which is equal to at least 5 occupied cells here to exist in order to find the total cost of this model. Therefore, sometimes there are a probability of fewer occupied or completed cells may appear in a solutions. Therefore, in that case, that solution we consider as degenerate solution. Therefore, this degeneration solution sometimes may require some remodifications. Therefore, there are basically 3 models or methods to find this solution set for this model. The first one is the northwest corner method. The second one is an intuitive approach or least cost method, and the third one is Vogels or penalty method. Therefore, when we come to the first northwest corner method, we can see also from the northwest corner method, it is a systematic approach for developing an initial feasible solution. It is one of the disadvantages of this in the northwest corner method is it is very easy and easily understandable. But its disadvantage is it does not consider into consideration in finding the total cost, the costs which is incurred by business enterprises in order to transport their products from their origin to their destinations. Therefore, to find a solution set through this northwest corner point, you should always start from your upper left-hand side top margin. You can consider the geographical location of this northwest corner is the upper left-hand side of the table. Therefore, you can allocate as much as possible. You can select the smaller value comparing the rows and supply and the demand side, and you can take the smallest value and you can allocate as much as possible until all demand and supplies are fully satisfied. Therefore, you can consider here to find this. This is the first original model. Therefore, the northwest corner point is here. Therefore, the demand here in this column is 50. This the row value is 100. Therefore, 50 is less than 100. Therefore, you can allocate here 50. Now, this will become 0. This one will become 50. The next northwestern point is here. Now, 150, here the remaining value is 50, therefore this 50 will be allocated here and this will become 100. Now this is already fully exhausted. Now the next northwest corner point here is this one, therefore here 100 is left, therefore you can allocate this 100 here, this will become 0 and then this will become 100. The next northwest corner point is here, you can allocate this 100 here, and also this will become 200. This will fully be exhausted. Then the next one, the next left one is this one, 200. You can allocate, and finally all the supplies sides and all the demand sides are fully exhausted by this transportation model. Therefore, to find the total cost, you can multiply the cost with its unit supplied, the cost with unit supplied, and you can sum. Therefore, the total cost will become $1,900. This. Therefore, the next method is the intuitive approach or the least cost method. Therefore, the least cost method, which is an easy approach, first you can find the lowest unit cost from all the table display, and you can allocate that the smallest value from either a row or a column value until all supplies and demands are fully satisfied. Therefore, these are the 4 basic steps that you should bear in your mind while considering the intuitive approach to find the total cost which is incurred by the business enterprise in order to transport the sand and gravels from the 3 farms to the 3 project areas. Therefore, through this first, here is a table. Therefore, the list cost is here. 1 is the list cost. Therefore, this is 150, 200. Therefore, the list is 150. You can allocate this 150, and this will become 0. This will become 50. The next list cost is 2, but the demand side is fully exhausted. Now you can skip to find the other list cost, which is 3, and now you can allocate 200. Now this will become fully exhausted. This will become 100. The next list cost is, which is exactly 4, therefore 50 and 100. You can choose the list which is 50. Therefore, you can allocate this 50 here. Now this will become fully exhausted 0, and this will become 50. The next list cost method is the list cost value is 5. Therefore, unfortunately, the demand side is fully exhausted. Now you can find the other list cost, which is 7. Already the demand is satisfied. You can skip to the other 8. Therefore, here the remaining value is 50. Here it is already 50. Therefore, you can allocate this 50 here, and this will remain with 0 absolutely. Already, which is occupied by project 1, 50 cubic tons. Therefore, this is fully exhausted. The next list cost is 9, 50. You can allocate the remaining value. Therefore, the total cost will become 100, not 1,800. Then, comparing the previous northwest corner approach, now this is the list 1, while comparing, because it is considering the cost issue in this to find the total cost. And the other one is VAM approach, the Vogels approximation method, which is the third method for determining an initial feasible solution. Therefore, here we should consider the penalty cost or regret to find the total cost. Therefore, here there are different steps that you should bear in your mind. There are basic 5 steps that you should bear in your mind in finding the total cost through this the VAM approach. First, you can construct the cost, requirement, and availability matrix. That is the cost matrix with column and row information. Then the second step is compute a penalty for each row and the column in the transportation table. Compute penalty. Therefore, the penalty is merely the difference between the highest cost and the next highest cost. And identify the row with the largest penalty, and you can choose that cell which has the smallest cost and allocate the maximum possible quantity to this cell. And in the step 4, you can repeat steps 1, 2, 3 for the reduced table until the entire capabilities are used. And in step 5, or in the last step, you will get the initial feasible solution. Now, for initial feasible solution, find the total cost. Therefore, based on this, here in the first row, the highest cost is clearly 8. The next highest cost is 4. Therefore, penalty highest cost minus the next highest cost, 8 minus 4, which will become 4. Here in the second row, 9 minus 5 will become 4. And in the third row, the highest cost is 7. The next highest cost 6. 7 minus 6, which clearly become 1. Therefore, the first allocation will be, there are 2 numbers appear with equal values with the highest 4 and 4. Therefore, here there is the ATI value is here. Therefore, by using probability, you can choose one best. Therefore, to choose one best from these 2 rows, we should concentrate on the Coleman values. And in the Coleman value, in the first Coleman value, the highest value is 7, the next highest value is 5, 7 minus 5, 2. In the second Coleman, the highest value is 6, and the next highest cost is 2, 6 minus 2, which is equal to 4. In the third Coleman, the highest value is 9, the next highest value is 8, 9 minus 8, which is equal to 1. Therefore, from 2, 4, 1, the highest value is 4. Clearly, the allocation will be in the second Coleman. Therefore, probably from this to highest value from the row, you can move in the row value and you will choose the smallest value. The smallest value is clearly 1. Therefore, from 150 and 200 value, you can choose this, the smallest 150. You can allocate 150 here. And this is the first step. And the second step also you can choose, you can find also the highest cost, the next highest costs with their penalty values. And also in the second columns also with penalty, already the second column is fully exhausted. Now our selection will be in the first and the third column. Therefore, here 3 similar values are appeared. This is appeared. Therefore, our next allocation will be here, and in the third allocation will come here, and also the fourth allocation will become will exist here, and the fourth allocation will be here, the fifth allocation will be here. Therefore, when we summing up the total cost, it will become 1,800. Therefore, this is the least cost while compared with the northwest corner, but it is similar with the intuitive approach. Therefore, to evaluate a solution for optimality, that is for optimality for a feasible solution involves a cost evaluation of MPT cells, that is rows to which no units have been allocated to see if an improved solution is possible. We shall consider 2 methods for cell evaluation. The first one is Steppingstone method and the Moody method. Therefore, Steppingstone, here in a Steppingstone method, this involves tracing a series of closed paths in a transportation table using one such path for each MPT cell. Therefore, the path represents a shift of 1 unit into an MPT cell, and it enables the manager or analyst to answer a what if questions, or what impact on total cost would be there if 1 unit were shifted to unused route. Therefore, the result is a cost change per unit shifted into a cell. And also you should reconsider the initial feasible solution and to find the best cost while compared with the other 2 methods. Therefore, you can consider the northwest corner method. Therefore, only the unoccupied cells need to be evaluated. Therefore, from the northwest corner point values you can bring here, and also all unoccupied cells. These are some of the rules for tracing these Steppingstone paths. The first step is all unoccupied cells must be evaluated, and except for the cell being evaluated, only add or subtract unoccupied cells. It is permissible to skip over unoccupied cells to find unoccupied cells from which the path can continue, and the path will consist of only horizontal and vertical moves, starting and ending with the MPT cell that is being evaluated. And you can alter this plus and minus signs, beginning with the plus sign in a cell being evaluated. Therefore, the general implication that means for a plus sign means 1 unit will be added, whereas a minus sign indicates 1 unit would be subtracted. The net impact of this shift will be determined by adding the cell cost with the signs attached, noting the result value. Therefore, based on this, here is the northwest corner values, which is with the total cost of 1,900. Therefore, the unoccupied cells are A3, B1, C1, and C2. Therefore, we can evaluate this A1, not A3, B1, C1, and C2. Therefore, this unoccupied cell A3, now, for example, take the A3 value, A3, to evaluate A3, first you should bring plus sign here and the minus sign here, plus sign here, minus sign here. Therefore, from the plus, minus, plus, minus, plus, minus, therefore, you can select the lowest value from the minus signs, that is clearly 50. Therefore, you can reduce in minus sign, this is the value 50, and you can add this 50 in a plus sign. Therefore, plus, minus, plus, minus. Therefore, here it will become 50. Here it will become 0. Because 50 minus 50, which will become 0, 100 minus 50, 50, 100 plus 50, 150. Therefore, the A3 value will become 8 minus 9 plus 1 minus 2, it will become minus 2. Similar for B1 also, you can take plus, minus, plus, minus. Therefore, 5 minus 1 plus 2 minus 4, which is clearly becomes plus 2. For C1 also, plus, you can skip. This is unoccupied cell, therefore you can skip. Plus, minus, plus, minus, plus, minus. Therefore, plus 7, minus 3, plus 9, minus 1, plus 2, minus 4. This will clearly become plus 10. Therefore, C2, here C2, plus 6, minus 3, plus 9, minus 1. Therefore, 6 minus 3 plus 9 minus 1 will become clearly C2 with plus 1. Therefore, now the highest value is minus 2. Therefore, we should consider this. The A3 is the area that we should make a remodification so as to reduce the total cost. Therefore, in A3 now, this is plus, minus, plus, minus. Therefore, 50, the minus signs, from the minus sign cells, you can choose the smallest value, that is 50, 50 minus 50, 0, 0 plus 50, 50, 100 minus 50, 50, 100 plus 50, 150. Now the total cost will become now 1,800 after remodification through this Steppingstone method. The other one is the Moody distributions, or the use of index method. It is a similar result will appear here. First, to find the cell cost, you can use this row index plus column index, which is equal to the cell cost. Therefore, the index numbers are determined sequentially in a manner dictated by the position of occupied cells. The process always begins by assigning a value of 0 as the index number of row 1. Therefore, the method will be illustrated by developing index numbers for the initial feasible solution for the Harley gravel, the northwest corner point you can bring here. Therefore, to start with, this is northwest corner point allocation values with the total cost of 1,900 while multiplying the cell cost with its occupied cells unit quantity, you can get 1,900. Therefore, to start with here, you can put the rows 1, 2, 3, and this is column 1, 2, and 3. Then always you should start with row 1. Therefore, always the row 1 index value, which is equal to 0. Now you can bring this formula, the row index plus column index, which is equal to cell cost. Therefore, always this formula will work only on occupied cells. Therefore, a row index, which is 0, this is unknown. Therefore, 0 plus K1, which is equal to 4. Therefore, the value of K1 will clearly become 4 here, which is the occupied cell. Therefore, 0 plus K2, which is equal to 2. Clearly, the value of K2, which is equal to plus 2. Here it is not. It is impossible. Why? Because this cell A3, it is unoccupied. And now we can here already K2 value, or the value of column 2 is plus 2. which is this cell is occupied cell. Therefore, row 2 plus K2, which will become 1. Therefore, the value of R2 will become clearly -2. And this is occupied cell. Therefore, it is possible to find the value of K3 because this is -1 plus K3 will become 9. Therefore, the value of K3 will become 10. And now, which is here, it is occupied cell. Therefore, the K value is 10. R3 plus K3, which is equal to 3. Therefore, the value of R3 will become -7 clearly. Therefore, for undertaking the cells evaluation through this north, considering the northwest corner point value, therefore cell evaluation, which is equal to cell cost minus row index minus column index. Now, undertaking this formula, you can find the similar values with the Steppingstone, and the total value will become 1,800 customer item. Therefore, already we can undertake in A3. Here is the A3, which is negative 2 values, while compared with C2, C1, and B1, all the remaining 3s are with positive value. Therefore, the remodification will be undertaken here in A3. Therefore, and by undertaking a remodification steps, you can obtain this value of 1,800. The next one is this assignment problem. Therefore, there are many situations where assignments can be made. Therefore, assignment can be made with workers to assign workers to different machines, clerks to various counters, salespeople to different sales areas, and service crews to different districts are some of the examples of this assignment problem. Therefore, the assignment problem, to undertake this assignment problem, now take into consideration this example. And there are 4 workers with 4 jobs. Therefore, to assign, for example, the worker 1 to job A, it will take 45 minutes. These numbers are the minutes that is which requires to assign each workers to these jobs. Therefore, to find the total cost here, not the total cost or the total time it takes for these workers to be assigned in these 4 jobs, you can use this assignment problem issues. Therefore, here assignment is made on the basis of 1-to-1. Therefore, number of jobs equal should number of machines or person. Each man or machine is loaded with one and only one job. Therefore, loading criteria must be set specifically. Therefore, the assignment problem with the number of sources and destinations are same, with the objective of minimizing the total cost. Then, to find to apply this assignment model, there is a worldwide known method, which is the Hungarian assignment model, which is formulated by the Hungary peoples. Therefore, which is considering only the concept of opportunity cost. Therefore, first, these are some of the 6 basic steps to find the time it takes for organizations or for the workers to be assigned in their 4 jobs. The first step is locate the smallest cost element in each row of the cost table, and you can reduce that table. And in the second step, consider each column and locate the smallest element and subtract from each element in that column. And you can find the reduced column table. And step 3, draw the minimum number of horizontal and vertical lines, not diagonal ones, that are required to cover the entire 0 elements. And step 4, select the smallest uncovered by the lines cost element. And step 4, repeat step 3 and 4 until an optimal solution is obtained. And given the optimal solution in the step 5, you can make a job assignment as indicated, considering the 0 elements. Therefore, locate a row with only 0 element, and in step 2, repeat A for each of such rows which contains only 1 0. And in step 3, if there is no row or column with only a single 0 element left, then select a row or column arbitrarily and choose one of the jobs or persons and makes assignment. Repeat steps A to 3 until all assignments are made, then determine the total cost. Therefore, based on this, now we can find the lowest element. In the first column, the lowest element is clearly 41 in the not in the row. First, let's start from the row values. The smallest is 14, in the second 42, in the third the smallest value is 48, in the third the smallest value is 41. Now the reduced value after reduction will become here. Then and find, you can also find the smallest element in each column. Therefore here there is 0, 0, at least there is 1 0. The only with no 0 element is column D. Therefore you can take the smallest value from the fourth column, that is 13, and you can deduct, and the value will become here. Therefore at least 1 0 in each row and 1 0 in each column. Then now draw the minimum number of lines to cover all zeros. Therefore the highest 0 here in the first column, I think. Therefore you can draw the vertical line here to cover all zeros, and then the next one is only one zeros. Therefore you can draw the second, the third, and the fourth. Therefore all elements, all zeros are covered by drawing two vertical and two horizontal lines. Therefore assignment is possible now through this, because all elements, all values are covered by drawing this 4 vertical and horizontal lines. Therefore the first worker is assigned here in the, you can choose the 0 element you can find to assign the worker 1. Therefore the only value 0 here in job B. Therefore you can assign worker 1 in job B, worker 2 in job already this job is occupied by worker 1. Therefore you can allocate this worker 2 in a job D, and worker 3 in job C, and worker 4 in job A. Therefore already you can take the original value 1B, which is taking 1B taking 40. Therefore 40, and also 2D clearly 55. 2D is 55, and 3C is 48, and the last one 4A 41. Therefore 40 plus 55 plus 48 plus 41, which is 180 minutes it will take to find the solution set. Therefore you can use also, this is your home-based assignment you can do by taking into consideration the above steps. Therefore this is all about chapter 3, the transportation and assignment problem. Now the next session we are going to have a discussion on chapter 4, that is a decision theory. Thank you very much for this session.